Thank you, sir, for providing the opportunity to speak here. I'd like to thank the organizers as well. The presentation I'm going to make here is about the water security in River Ganga Basin. And if you follow it, you would be able to make some links or draw some parallels between Indian mythology regarding River Ganga and what the condition is and how we can take care of that. So we'll be starting with the importance of water. We need water to drink. There are certain areas in the world where the availability of water is this much. I mean, people have to drink water from the, whatever is accumulated on the roads. We need the major consumption of water is in agriculture. We need it for cleaning ourselves and our clothes as well. Animals, they also need them. And industry, that is another big consumer of water. Now, talking about the term water security, there are many definitions given by various organizations and people, but the definition that majority of the people agree with is the one given by Global Water Partnership, and it says that water security at any level from the household to the global means that every person has access to enough safe water at affordable cost to lead a clean, healthy, and productive life while ensuring the natural environment is protected and enhanced. The last part is very important and is usually neglected. Now, what are the effects of population on water security? There are some facts that I've collected over here. World population has risen by almost 80 million a year between 1992 and 98. So that is a large pace we are moving on. Population is on a rise. Water resources are limited. This is a small diagram I have created to explain the conditions. When population rises, the food demand obviously is going to go up. That means we need more agriculture to be done. That means we need more water. And our daily needs for drinking, cooking, washing, bathing, we need water. So the demand increases with the population anyways. More population means more people to give better lifestyle. That means more industries. More industries means more water. And more people, more infrastructure. So more water again. So that is how the demand of water increases with population. We need to understand that around 450 million people worldwide are living in the scarcity of water. And around 2.8 million people in the world lack access to safe drinking water. So that is the situation right now globally. This picture here will show you the water stress in various river basins, and this is the area of focus, River Ganga Basin, for us right now. And if you see the scale over here, we are in high water stress area, level as per this figure. Another burning issue, climate change, which is many times ridiculed by many people, but apparently is a big issue. In a simulation, the mean surface temperature for entire planet has been estimated to rise by 1.4 to 3 degrees Celsius under low emission scenario, and up to 5.8 degrees Celsius under high emission scenario between 1900 and 2100. So that is the level. Obviously, this is a result of a simulation. The practical results might be very different, but there is some correlation to it. So in a low emission scenario, a rise of 1.4 degrees Celsius, that is a cause of worry. Recently, there was an article about melting ice in Arctic, which is a big issue. At certain places, localized temperature has risen by almost 10%, although still the temperature is in negative side of the zero, but it is a cause of worry. Accelerated melting of glaciers is a cause of worry. IPCC predicted that by year 2300, the Ganga glacier, the glaciers which are feeding River Ganga, will be in a bad condition, really bad condition. Almost half of the world's mangroves have been flooded. We have a large amount of mangroves growing on the downstream of River Ganga where it empties into Bay of Bengal, and there were floods in Bengal. I'll be talking about how the problems can, how a small problem, you can't say small, but flooding can lead to political tensions between some nations. I'll be talking about that. Okay, so talking about the water requirement of the country. By 2030, it is predicted that we will be needing around 1.5 trillion cubic meters of water, which is almost double of what we needed in 2013. In 2006, the per capita water availability in India was 1730 cubic meter per year. And when your water availability is less than 1700, you are the nation is considered to be under water stress. So we are closing in onto a real bad scenario right now. The facts about River Ganga, I think most of the people would know about that, but there are like 968 glaciers feeding River Ganga with 214 cubic kilometers of ice or water. The length of the river is around 2,525 kilometers. The catchment area is 108,000 square kilometer. That's a big figure. The cause of worry here is that the population density in River Ganga Basin is around 550 persons per square kilometer, which is amongst the highest in the world. Just a brief of look at the River Ganga from aerial view. It starts right in Uttarakhand and goes all through Uttar Pradesh, Bengal, Bihar, and Jharkhand, and then to Bangladesh, a part of it, and West Bengal, then goes into Bay of Bengal. Now, one thing is to be understood over here, that while most of the tributaries of River Ganga are also originating in India, but there are 4 tributaries that come from Nepal, and then some distributaries on the lower side or the downstream side, which empty through Bay of Bengal. That makes River Ganga international river, and any problem in River Ganga can be a reason for political tension between the countries. Okay, so these are the average dissolved oxygen levels that were, the data was taken from 1986 and 2008. You can see in 1986 the condition was pretty, the dissolved oxygen levels were going down, and in 2008 a lot of progress has been done. However, still, this red band over here is the area where DO level should not come. DO level should always be above this. We are in much better situations, but if you check at local levels, there are certain big cities where you will find the dissolved oxygen levels falling into this band. Then this is the average BOD or biological oxygen demand in River Ganga at different cities along its length. And in 1986, you can see the BOD is going as high as 16 ppm at Allahabad. However, the position had improved a lot during 2008, but still there are certain cities where their problem still persists. These are just some graphs where I tried to establish some relationship between the groundwater level and the population. Though not very significant results were achieved, but you can certainly make out that the way the population is rising in a city like Haridwar, the groundwater level is also receding up. This is the rainfall pattern for different states in the Ganga Basin, and you can see the fluctuations in the rainfall pattern. For certain states like Delhi, Haryana, you can see a dip coming out in the last few years, which is a cause of worry. And when you come to Uttar Pradesh, again, you will see this dip in both the graphs, west and eastern Uttar Pradesh. The problem seems to be taking place. This is the rainfall during the monsoonal season. And in monsoonal season, Uttar Pradesh again is showing certain problems. You can see a dip in the graph, not very significant though, but in long term it can have really significant impacts. So these are some of the graphs that were plotted. Now the important thing is to understand the impact of water insecurity in River Ganga Basin. There are certain local impacts that we can predict, like water shortage, food shortage, and frequent floods and droughts. Now, when the climate change has its impact, we can assume that we'll be having a lot of rains restricted over a very short period of time, maybe in 15-20 days, which can be a cause of floods downstreams. And the rest of the seasons, if this continues for a long time, the summers are going to be really dry, and the river Ganga is expected to be drying off during that period. Political impacts, environmental migration. You'll see the people migrating towards the areas which are richer in availability of water. And interstate conflicts. The conflict between Haryana and Punjab, we are seeing right now, between the states for River Kaveri, we are witnessing now. And then there could be international disputes similar to this as well. Social impacts, spiritual, religious sentiments. Well, Ganga, we can't imagine our life without River Ganga. It has a lot of spiritual and religious significance for us. So we need to take care of the river with all that we can. We can have problems similar to the refugee issues. Geographically impacts, there could be change in soil dynamics, and there are many studies which suggest that the state of Rajasthan and its desert was a cause of similar pattern. I mean, change in soil dynamics. Then global impacts, I talked about that. Ecological impacts, obviously the river chemistry or the river, the life in the river is going to suffer, which is going to have a long-term impact anyways. Well, population, I talked about this, 550 people per square kilometer, and we have around 45% of the Indian population living in this basin. So there's a pressing need of restoring the basin. Climate change is going to be a problem. I discussed about that. 2013, we witnessed floods in Haridwar. We can expect similar problems if no action is taken. There have been some works done in past. Ganga action plan was taken up. Much improvement was done, as I showed in the graph. Although there have been changes and the scenario has changed in India long after that, there has been a lot of infrastructural development. The population has grown a lot. So we need to take care of that. There was a study done by the IIT consortium, and this was a summary of that study where they suggested that we need to take all these parameters. Integrated catchment management is what has been suggested for taking care of that. And it has worked successfully for European Union and at some places in US as well. So that is what we need to see. I did a case study on how the integrated catchment management was planned and done in United Kingdom. And there is a summary of that. Due to the shortage of time, I'll not go into the details right now, but if anyone would like to discuss about that, I would like to talk about that. The conclusion is that the assumptions that were taken, there was not sufficient proof for that, the diminishing groundwater levels and population growth. The trend in rainfall is obviously we need to go in deeper studies to establish anything on that, and need to consider the restoration on the basis of that. Political will, which is apparently proving right now in a strong way, and if we go strongly in this direction, we will certainly be able to make difference. Integrated catchment, as I talked about, is something which we need to consider while taking care of river Ganga, and which can prove to be a model for other river basins in the country. These are just the references, and thank you.